So 1.5, if you've been following along so far and you've watched problems 1 through 4 already for chapter 1, then this problem is going to be very easy for you. So I'm going to direct this video more toward people who might just be joining for this video. Maybe you were assigned this for a homework problem and you haven't gone through 1 through 4 yet. So this one might not be review for you. So if this is just review and very easy, you could just skip this one because I am going to kind of take this one a little bit slow. It's asking to find the probabilities for up and down in the z direction, and then the probabilities for up and down in the x direction. The z direction is very simple. And again, if you've been following my video so far, you can probably just look at this and already know the probabilities. But if you're just jumping in for this video, you might not be able to see that yet. So we'll walk through that. Now this is normalized already. If you're not able to see quickly yet that this is normalized, then that's totally fine. You can either work the math out or trust me that it is normalized. Another way to do it is you can just square both of these terms and then add them together. And it should be 1. So if you square 2 over root 13, that's 4 thirteenths. Square this, that's 9 thirteenths. Add them together, and it's 13 thirteenths. So this is normalized. And so we'll just jump right into it. So again, we want to find out the probabilities for up and down in the z and x direction. So we'll start with z. So we'll say up in z, and so we want to find this, and we want to find the probability of it. So first we have our bra for up, so we just write that out as is. We're going to basically multiply it with our state here. So we can just write that out, 2 over root 13 up plus I 3 over root 13 down. Okay, and so then we kind of just distribute this plus here. So we have a plus and a plus, so we'll keep that. And again, we're going to be squaring this. So 2 over root 13. And then we have a plus and a minus, and that's going to cancel out. Basically saying, if we're oriented in the down direction, what are the chances of us reading an up? And it's 0. If we're oriented in down, we will never read an up. It's just like a coin. If the coin is heads up, what are the chances of you reading a tails? 0. It's never going to happen. So this term just cancels out. And vice versa. So here, if we're oriented in the up direction, what are the chances of measuring an up? 100%, so 1. So that's why we keep this term. That's why we drop this term. So anyways, so that's it. So we can square it, and that's going to equal 4 thirteenths. So probability of us reading an up in the z direction is going to be 4 thirteenths. So if we did the math right, then we should see 9 thirteenths chance of reading down, because there's only 2 states in a spin 1/2 system. So let's go ahead and do down. And so same thing, we're going to distribute this down. Now this time, the down and the up cancel out. And then the down and the down, we'll keep that. So we have I 3 over root 13 and square that. Whenever you square something with an imaginary number, you have to take the complex conjugate. So we have I 3 over root 13 and multiply it with this complex conjugate, so negative I 3 over root 13. And what we get is I times negative I is going to be negative I squared, and I squared is negative 1. So negative and a negative is just 1. So our i's just cancel out, and then we're left with 9 thirteenths, which is what we expected here. So down in our z direction equals 9 thirteenths. All right, so that's for our z direction. Again, we could have just looked at this and saw that this up is going to be this squared, so that's 4 thirteenths. Down is going to be this squared, and that's 9 thirteenths. All right, so now for our x directions. So up in our x direction. Now, I'll take a minute to kind of show what happens here when you change directions. So by default, everything is sort of oriented in the z direction. That's why if you just have like up with no subscript here, that's just by default going to be the z direction. It's typically not written. So if there's nothing there, it's z. If it's a different direction than z, then we'll write like x like that. So in this Stern-Gerlach experiment that chapter 1 is about, basically what they did is they shot some particles into some detector, and this is oriented in the z direction, and found that half the time, 50% of the time, they read upspin, and 50% of the time there was a downspin. All right, and then at that point, let's detect it again in the z direction. And then in the up direction, now we have 100% up, because we're only taking the ones that we already read as up. And now, because we were only taking in the ones that were spin up, they're still spin up. So that was kind of expected there. That makes sense. So then we have here 0% up and 100% down, right? Because we're only taking in what we read as spin down, so they're still spin down. Nothing weird has happened. So now instead of, I didn't really need to erase all that, but I will anyways. So instead of reading it oriented in the z direction, now we're going to have our detector oriented in the x direction. And now what we find is we're only taking in the upspin in relation to the z direction. And what we see here is that, again, we get 50% upspin and 50% downspin. So if all we're taking in is the upspins from the z direction, we get 50-50, whether we get up or downspin oriented in the x direction. So that's what the experiment showed, and the ket to show that is the up direction in, or the up state in the x direction is represented by 1 over root 2 up plus 1 over root 2 down. So if you square each of these, you get 1/2 up and 1/2 down. That's the probabilities that you'd read up or down. So that's going to be our ket for up in the x direction. And then our bra, basically the same thing. 1 over root 2 up plus 1 over root 2 down. Okay, so that's what we need here. This bra right here is what we need there. So we'll go ahead and write that out. 1 over root 2 up plus 1 over root 2 down. All right, times our state. So 2 over root 13 up plus I, 3 over root 13 down. Okay, so we'll go ahead and FOIL this out. So we have an up and an up. We'll keep that. So that's 2 in the numerator, and a 2 and a 13 makes 26, so root 26. And we're going to be squaring this. And then so our outer terms cancel, inner terms cancel. And then we have a minus and a minus. So we have plus I, 3 in the numerator, root 26 in the denominator, and it's going to be squared. And we can't just square each of the terms separately. This is a binomial, so we need to treat it as such. So 2 over root 26 plus I, 3 over root 26 times, remember to complex conjugate this, so 2 over root 26 minus I, 3 over root 26. Okay, and then so we'll just FOIL this out. So we've got 4 over 26. We have a minus I, 6 over 26. We have a plus I, 6 over 26. This kind of looks like a 20. There we go, 26, 26. And then a minus I squared, 9 over root 26. Nope, not root 26, just 26. Okay, so these terms cancel out. I squared is -1. That's going to flip the sign. So then that's going to be equal to 4 26 plus 9 26, which is equal to 13 26, which is equal to 1/2. So our up in the x direction is going to be a 1/2 probability of reading that, which means we should, if we did the math right, we should get a half for the down direction also. So let's go ahead and do down here. And so the down ket is going to look like 1 in the x direction, 1 over root 2 up minus 1 over root 2 down. The reason for the minus here is because there's some complex phase. It has to be different from this. So there's some complex phase that it's like e to the I theta, but we don't actually see the e to the I theta because that term ends up becoming -1, which is why that's a negative there. So the bra state for x is going to be 1 over root 2 up minus, and we don't flip the sign here, there's no I, so we don't have to complex conjugate that. 1 over root 2 down. All right, and then so it's basically the same thing. The only difference here is a minus sign. Okay, so we'll FOIL this out again. So an up and an up, we keep that. So that's going to be 2 in the denominator, or in the numerator, and root 26 in the denominator. Those cancel, our minus and our minus. We have a minus I3 over root 26. And we'll square this. Now, if you remember before, we had the same thing. We had 2 over root 26 plus I3 over root 26 before. But when you multiply this, when you square this, you have to multiply it with the complex conjugate. So it was plus I minus I, and now it's going to be minus I plus I. So it's going to end up being the same thing. But I'll do the math anyways to show that. 2 over root 26 minus I3 over root 26 times 2 over root 26 plus I3 over root 26, which, if you can see it now, it's going to end up being the same thing, but we have 4 over 26 plus I 6 over 26 minus I 6 over 26 minus I squared 9 over 26. All right, these terms cancel again. That I squared ends up flipping the sign. And again, we're left with 4 over 26 plus 9 over 26, which is equal to 13. 26, which is equal to 1/2 as expected. So minus in the x direction is also 1/2. All right, and those are our probabilities for the z direction and the x direction. Hope that helped.